More Samsung TV stuff. I got a Samsung Frame TV. I thought those were supposed to be the top of the range premium, but it seems like the Q7 TV we were looking at the other day is better in terms of sound and picture quality. A little bit disappointed there. And even the remote that come with the Frame TV is really ugly compared to this very nice feeling and looking one that came with the Q7 TV. So a little bit disappointed by that. I was expecting to get something really good with the Frame, but apparently not. You get something not so exciting. So now we've got 3 of these. I wrote on that Frame so that we don't forget, but it's got something weird going on there. We might have to take it apart and have a look. Again, this one doesn't come with the component and composite input, which is a bit disappointing. I got the TV cheap because the One Connect cable is broken. And also the screen has quite a lot of scratches on it, on the TV, but they're not that visible when it's running. So yeah, something's happened here, and the fibers are all broken. So that means we don't have much to lose here. We can take apart both of these ends and look inside them and see what's going on. And I'm wondering if we can try to repair this. We'll need to determine if it's plastic or glass and then come up with some sort of plan to see if we can get it working again. The roll thing that this One Connect fiber came on appears to be different to the one that we looked at before. If we look at the sticker that's on the bottom of my other one and this one here, we can see that has an A and my other one has a B, and that, which is maybe just a serial number, is also different. So annoyingly it's got this sticker that doesn't peel off easily. But I'm wondering if that BN number is all the same, other than this is A and that one's B. So we'll take apart the connectors and have a look inside them. Maybe we'll take a look inside there and see why it's doing that. What I have noticed, so I've plugged my one of the other One Connect box into the Frame TV and it works. And I checked in the service menu and you can specify whether it's a Frame TV, so you can make it frame or not, I presume, by adjusting that parameter, which is interesting. The reason why I was in there is I was changing the region because I wanted to use that South Africa version that has got the component and composite input, and so I changed the region and factory reset it, and now it's all good. It tunes the local channels and I can use those inputs. So I'll set up a microscope type thingy here, which we can take a look at. And so we can see this is the TV end, and if we get the broken part of the fiber in there and see if we can focus on that. Yeah, so it's got this fluff which is all twisted up by the look of it, and then you can see the fibers there and then lots of other crud. This TV that I got was really dirty, so it's obviously been in a terrible environment, which is probably what led to this fiber getting broken. Yeah, I had to scrape a lot of crud off of the screen and around the edges of the frame before I wanted to bring it into my house. So there's the fibers. I'm wondering if it would look better if it was on a dark background. Okay, with a dark background, it's a lot easier to see because the auto exposure works differently, I think, something like that. Anyway, we can see there's a clear tube that the fibers are in, and then they are broken. Fluff which surrounds them normally. If we go to a part that's not broken, yeah, it's just fluff with fibers around it. So hopefully there's no damage in any other part of this cable. It's really difficult to know. I'm not sure if that fluff that's in there is just one piece that goes alongside the fibers, or if it is surrounding them completely. It's really hard to tell. It looks like it's just one sort of rope that goes alongside the fibers. So perhaps we'll cut it back a foot or so in, and that way, if this has been pulled quite hard and it's upset them, hopefully not matter. And the other thing I was wondering is, if I'm going to try to join this, would it be better to remove some of the length so that losses and reflections created by joining it don't have... so if we create loss, the overall length is less, so the loss is less of a matter. So if I make the thing shorter, then adding a bit of loss where attempting to join it will have less impact. It's damaged almost exactly halfway along. So this is the 5-meter version, the one you get by default, without paying heaps more money to get the 10 or 15-meter version. So there are a few little dents in it, but the other one I've got that works fine also has a few little dents here and there. I think it's because it's been rolled tight on this reel thing, and that causes it to get a little bit squashed, but it feels okay. So let's cut it. I'll cut off about that much. So I was going to try cutting it with a really sharp knife and then see if we can inspect fibers. That might help tell us if it's glass or not. And then we'll try melting it. And that will perhaps also tell us if it's glass. We'll use a 1-connect box as a chopping board. That seems like a good idea to me. Get a new part of the blade. Sounded kind of glass. So they're all cut and that fluff stuff remains. And the other thing is, how do you strip that outer insulation off without nicking into the fiber cores? I have to devise a way of doing it. Okay, we've got two ends now. We're also going to have to attempt to join it. We have to identify the cores. So we're going to have to try shining some light down them. So we can pull this out now. Let's see. So the fluff appears to be fairly evenly distributed. So it looks like fluff is quite well dispersed within the bunch of fibers. Now we've pulled back the fluff. There are 8 fibers. So after cutting them with a sharp knife, the ends are still very rough. I guess you need special equipment to cut them cleanly, or you need to sand them down using a jig that holds it straight. No, you can do that with the 1mm plastic optical fibers, like the Avago Versatile Link stuff, which I've used a little bit. And there's a little jig that you put it in and then sand it down to make the end smooth. So perhaps we'll try snapping one of these and see what happens. The pin's pretty sharp. Okay, so pin's almost completely has not snapped, which would perhaps suggest that it's not glass. Okay, it does snap right at the end, so maybe it is glass. Okay, should we try melting it with a soldering iron and see what it does? Okay, let's try melting this with a soldering iron. A little bit of smoke comes off. It does not appear to melt. It's probably glass. Something interesting has happened. Let's look at that close up. It seems like it's a... yeah, you can see. I think it's a clear plastic jacket with a glass fiber inside it. That's what it looks like. See, we've managed to burn away an outer part and leave an inner piece exposed. So I think that might be the glass. That's interesting. Okay, let's see if it would be possible to strip the plastic material off the outside. And we'll just roll it around a sharp knife, I guess, and see what it does. Oh yeah, that seems to work. Not sure. It's just slightly sliced the fluff, but didn't seem to damage it. And if that was in focus, I don't know what's wrong with the camera, why it won't keep focused lately. Okay, so it seems feasible. You can strip this stuff pretty easily without causing any damage to the fiber cores. Okay, in that case, we should be able to prepare these ends. How long would we need to make them in order to be able to rejoin this stuff? Probably need to be fairly long, because we've got to identify them and then we got to fuse them somehow. I'm wondering if you just try some resin. If the cutter's clean enough, you put resin on it and the resin will seep in enough to tidy up the end and make it clear and transparent. I really don't know. Just making this up. But yeah, if you could get good enough clear resin, create a clean join. Perhaps we'll give it a go. We haven't got anything to lose because the cable is already wrecked, so we're not wrecking it. Can't really wreck it more than not working because it already doesn't work. Try and get all this fluff out of the way. Cores, and then we'll undo the other ends. Well, yeah, then we'll strip the ends. We're going to take these apart, and then we're going to try shining light down into these fibers so we can ID which one goes where in the ends. Then we can mark these with some permanent pen, try and come up with a creative way of joining them, and we'll mark them just with some little dots. It's really well wrapped around the fiber cores. It might also be attached to them because of the jagged end that we cut on them. So I guess we've done the easy part. The tricky part is taking apart these ends, as we discovered that other time that we tried to do it, because they're very well clipped together. Okay, what's the easy way to open these things? I don't think there is an easy way. I don't think we took apart this one last time, didn't we? To look at all the transmitting stuff. Let's take this one apart first. It's just really strong clips down these long sides as well as the short sides. Just stretch it out a bit to start off with without creating injuries. Oh look, we actually got it to start coming out. That's extremely promising. Maybe we can get it out without making too much mess after all. Or not, because just messed up the other side. Look at that, we got it open without too much difficulty. That's quite amazing and quite unexpected. Well, it's not fully out, but it's, yeah, there we go. Look at that. That's great. Yes, we've got to desolder those parts, so let's get them both to that stage. There you go, it's coming out. Making a bit of a mess of it, but it's coming out. Is this what you need a spudger tool for? There we go, that came out. I think these housings are universal, are they? Probably not, because there's a flat on one side on one of the connectors, and does that mean you just put it up the other way? Don't know. But the way these work, there's a flat there on that one, and there's a flat there on that one, so you can't put them around the other way, because obviously one has more transmitters and the other one has more receivers. Okay, we'll take the metal covers off and take a look inside. An easy way to open these without distorting them too much. Okay, it's opening up. Oh, it was opening up. Good, good. And now we need to solder. get the pressure on it first, because otherwise the soldering iron, it's not actually going to desolder if there's no springiness to spring it out to break the solder connection. Is it going to come off? Oh, there are more clips there that I haven't done yet. Okay, so we've got to bend these ones out, otherwise it's not going to pop open. Nearly, there you go. Here's one of them was open. Second one's open. Okay, so that's the one that we've seen in before. The transmitting side. And this is the one we have not seen in before. Oh, that also, the arrows say that that's also the transmitting side. But it is the TV side, it's got the TV logo on the thing there. Okay, so it's the part number there has got an R in it. And whereas that one has a T in it. A version 2.1. What I wonder is that chip the same at both ends? We can use the choice microscope thingy-mabob. Anyway, let's have a look in here. Genome GC1903. Ah, 1903. I'm pretty sure that has the same marking on it. 1903. So they're the same chip at both ends. And there's the same business going on inside here, the same at both ends. Got a little die thing on it, and then the top one has got a large one on it. And then in this one, seems pretty much the same. I thought that'd be quite a bit different. So that's strange. It's still going to be this one here and that one there are paired together, because that's where all the high-speed pairs go to. You can see better on this green one, and then this is some auxiliary stuff. But it's very surprising that they both look pretty much identical, although they're not. That one there has got two extra doofies there, which don't exist on that one. So there is some difference. Not a huge amount of difference. I'll try and take some photos of this stuff close up so we can look at it a bit easier. Got a picture of the connectors here, and I've been looking at it, trying to work out, would the fibers be crossed over between the two separate four-way connector things, or would they be using the same ones in the same order? They've got a red dot there, which presumably is on the cable part. This looks like a plug that plugs in, so that allows it to be assembled in the first place. So I assume that these four pairs here match up with these four pairs here, which all go into the connectors that have the red dot on them. And I assume that one would be a transmitter, the one with the T there, and the other one would be the receiver. They look very similar, but up close there's slight differences between the die of that chip thing that's in them. And then for the additional channel of data, it looks like there's another pair which goes coupled by those capacitors, and then there's two other signals there and there. So again, I assume that that wire there, or that fiber there, would be the same as that fiber there when you join it back together, or if it's not broken yet. I'm not sure if there's any way of determining that. Let's have a look. So when you look up close on this one, which is the receive, we can see a kind of die thing in there. I don't think I've got anything small enough to be able to point to this stuff, but there's a screwdriver. But what's happening is there's an IC, integrated circuit of some sort there, and there's a die, and that's mounted on the circuit board. And then there's a laser or receiver type thing mounted on the board there, and you can see the bond wires going over to it. And then there's a lens that reflects the light this way towards the fiber tips, which you can see there, or receives the light from the fiber tips. So that's the receiver side, and it's very similar on the transmit side. T there, transmit, which looks almost the same, but in the IC die there's some little circle shapes, so it is different in some way. And it also looks like there's only one bond wire going over to the transmitter thingies, whereas the other one had two. So that's a difference. So if we look at the other side, you can see there's still 4 dots, but the bottom one is a darker color there, and the 3 there are lighter colored. The middle one there's got 2 bond wires to it. The other ones all have 1. And then on the other connector, it's the same. Those 2 capacitors there, that looks like a differential signal that goes into that die, and then that drives or receives something. Very difficult to know what that actually is. I've been trying to find some information about it. So the only information I found is this tweet that I happened upon the other day just by chance, which shows a very similar thing is used inside optical HDMI cables, and it's apparently called a vertical cavity surface emitting laser. So there's a picture of one here which is very similar to the one that I have here with that connector thing on it and that stuff and that die, and there's a close-up picture of it. It's very similar but not the same as the one that I've got. We're going to try and find which fiber goes to which. So I've got the red dot up the top there, and it goes to this cable with its 8 fibers, and we're going to use an LED, red LED, to try and identify where it goes. But the light that gets through is so small, if we turn off the light there, we can see a small dot coming up. So I've got a pen. I'm going to try and put a mark on the glass when we find one, depending on what one it is. Starting with the top one, which will have 1 mark. I guess we're going to go through all the ones that belong to the other connector first, of course. Okay, so there's the first one, that's the top. Very small glow there. So that's going to be called 1 by having 1 mark on it. If this pen can draw 1 mark, yeah, put 1 red dot, and the next one's going to have 2. Well, the next one down is going to have 2. That one is the 4th one, so that one's going to have 4 dots drawn on it. That's the 3rd one, so that gets 3 dots. That's the 2nd one, so that gets 2 dots. So now we repeat it, and I'm going to use a blue pen for the other ones. Now these ones will all be in there. Well, they're shown up a little bit differently. And then we repeat it for the other end of the cable. Well, all the fibers now have a mark indicating the connector they go to and what pin on the connectors they belong to. I'll put a blue dot at the top of that one to help us remember what happens. So that indicates the 1-1. Now, I'm wondering if there is a temporary way of joining these together to prove if this thing will work connected in that order before what, who knows. Before I try and track down a joining thing. Yeah, we'll see what happens. Alright, I'll get back to you if something interesting does happen. While we're here, let's see if we can work out what's wrong with that thing. Why is that poking out? Now that we know how to get into these, well, sort of. Pull it from the sides. And it undoes itself. Maybe it's been dropped or squashed. So the problem is, it's very dirty inside, but the circuit board's been pushed down and it's gone over the edge of that clip part. Wow. This had some very rough treatment. I don't know if someone's been in here before or they're just rough with it. Strange. Anyway, let's just take it apart and have a look anyway, just to see if there's anything interesting going on in here. Remember last time there was that heatsink that you can't get off. And the tuner has a thermal transfer block. And the juice is coming out of that. Juicy stuff. I wonder if the heatsink will pop off of this one. I think it will. I think it already has. Looking down there, it's on such an angle that I think the heatsink has already come off. So that's very interesting. That might get us a better look at how the connections go into the One Connect cable. So we'll try removing these little pegs. Slippery. I wonder if this has been in a bad environment and got super hot and that caused the thermal pads to go juicy. Maybe it was left in the sun. I want to destroy very thin tracks that are around here. Okay, oh, there's another one over here. Squeeze these things out carefully. Try not to bend the board too much. Well, someone's already done a good job at that. Ooh, it's not very good. So, is it still attached? Despite what I thought. I think it's only attached on one corner. The back corner of that IC, or back side of it, seems to be attached to the heatsink, but not the rest of it. You can get the whole thing to peel off. I want to get that clip out, but unfortunately it's... Okay, the clip is now out. Putting a mess over everything. So it rotates. It must be a sticky pad then, not glue. Wow. So it is a sticky pad and it was only attached at that corner. This part here has never actually touched it. Well, not recently. That's amazing. I wonder if that's harmed this chip at all. So it's a DNIE, and some of it was extremely well attached, and most of it wasn't. It's left some residues. Now we can actually see this board for the first time. So that's very interesting. It's got two dies on it. The HDMIs, maybe that's some kind of HDMI multiplexer thing, and that's a processor. Does look like all the HDMIs are going into that corner. Again, annoyingly, it doesn't have the component and composite. Now I know how to go in the service menu and enable that kind of stuff. I wonder if it could be attached. There's a few components missing there. Say AV, filtery type things. I wonder if it needs any more than just those. It seems to disappear over here in these tracks. What's also interesting is the tracks from those connectors seem to go up to some sort of test point thing. Is that a pinout of it? Ident. There's ident AV, and then it's got CVBS out, AV1 ID, I think. 5 volts, something else L, something or other EN. And then there's that, which must, maybe it refers to those test points. Maybe that's those three, that's those. Just double-sided. And it's got COM ID, something ground, and then AV. CVBS, and then this one EEPROM select sys something EEPROM VCC. That said CVBS out on it, didn't it? Does that mean that there's another output from this thing that is possibly used in testing or setup? We need to join onto that. That is very interesting. CVBS out. So it doesn't appear to have a track going to it. Would it be better to use the microscope thingy-me-bob for looking at this stuff? Could well be. Oh yeah, why weren't we doing that from the start? Okay, we're looking at a microscope type output now, and we can see the die, which looks... oh, it's just covered in thermal paste, and there's the other one. Those are integrated onto a chip type deal, but we were looking at these test point things over here, and it looks like the one that says CVBS out doesn't actually have a pad going to it, or a track going to it. So maybe that's not possible. Comp PR component PR signal, presumably. And the other side had similarly a V2 CVBS, no track, and ground IO com ID Y. The PR was the other one PB. So it looks like it could have component stuff on that connector as well as other stuff. And then that one, oh, it's all sticky. It says FA net RX switch power. Oh, okay. And then something com SCL, which will be serial clock, like a I2C. It's got system in reset maybe. EPROM VCC, something FA net RX. Yeah, I wonder if you can turn it on with that power switch and then control some stuff. See what does the other side of that connector do. EPROM, SDA, write protect ground, FA net TX. Is FA net what goes on this connector, which they call service or something from the outside? Service, I wonder if that just accesses that connector. That's possible. There's a little group of components here. Switch power delay 2. Strange that the CVBS output one doesn't have anything going to it. That's a bit weird. Okay, so let's look at where the One Connect cables go. So that's the One Connect connector. And I need to zoom out of it, and there's the thing plugged into it. So we can see there seems to be 4 signals, then one with 2 pads, and then 1 pair, and a bunch of other stuff, and then 3 more pairs. Does that map anything? Oh, look, there must be more sets of data lines than what we think, perhaps. To get them both in the same frame, we maybe need to go to the camera to see this better. No sort of high-speed data things on the back, but on this side there's 4, 5, 6. But the pinout is weird. Pinout doesn't seem to match. Problem here with lack of light. Oh, let's just zoom it in. Okay. I need to do it a different way.